we're going to try this with a webcam and do the 7-2 notes from the classroom. So 7-2, we are doing properties of isometries. Now this word isometry is definitely one that people forget. So you're going to want to highlight this or mark a little star next to it. But an isometry is a transformation and this board is a little delayed. It's a little bit annoying to write slower. A transformation in which that's an N, of course, the preimage and image are congruent. That looks terrible, but so the preimage and the image are congruent. In other words, the size and shape stays the same when you do your transformation. Okay, so we are really only going to be dealing with isometries in Chapter 7. We will do some non-isometries when we do similarity. So ordered pair rules. So rules have a specific format. You're going to see them in a coordinate format. But basically the rule x plus h and y plus k results in a horizontal move h units. So for example, if I started right here, the horizontal moment, I would slide over h units. And then from there, I would slide up or down k units for the y value. So obviously with the x value, you're going left or right. And with the y value, you're going up or down. Okay, this can also be expressed as the vector, as we've talked about before in vector notation. Okay, now a rule starts with a coordinate, and then the notation, you draw an arrow, and then you get the new coordinate. So it looks something like this. Okay, so you see you have your original point, and then that basically maps onto the new point. Now, for example, if I had, I don't know, -1 and 3, and then I was going to apply a rule. Let's say the rule had going right 3 and then down 5, something like that. So let's say this said x plus 3 and then y minus 5. So you would take your original point and apply that rule. So -1 plus 3 would be a +2, and then 3 minus the 5 would be a -2. So if I was going to apply the rule of x plus 3 and y minus 5, this would be what's called the mapping for that point. So this would be the original point, and this would be the new point. Okay, next. So, for example, here's an example of a rule. So what you do is you take all of these points, you basically take this polygon, and you slide it over 2 and down 3. So why don't you pause and find all the new coordinates. Okay, so basically there's 2 ways to go about this. The first way would be obviously take each of those points. So n here is at -2, 3, sorry, -3, +1, 2, 3, 4. So -3, +4. And then the new point n, we would call that n prime, would be you add 2. And then here you would subtract 3. Okay, so n prime, again, you just slide right 2 and down 3. And this would be n prime. Now, one way to do this is to do this mapping for each one of the points, M, O, and P. Another way you could go would be to take the original point you moved. So I moved N here. And then you just basically copy the polygon since you know it's an isometry. So if I'm starting with N, I know M is down 1 and left 3. So from here, I go down 1 and left 3. This is a different way to go, but it would also result in the same shape. That would be M prime. Okay, and then N, you go to O, you go right 1 and down 1, 2, 3, 4. So right 1 and down 1, 2, 3, 4. And that would be O prime. And then to get to P, from O, I go down 2 and then left 3. So from O, I go down 2 and then left 3. Now this will result in the same shape as if you did all of these points right 2, down 3. But here is my image from the given pre-image. Okay, so that would be a translation. Next. Okay, transformation where you have 2 negatives here. So these are very, very straightforward. Whatever sign you have on this X, you just change the sign for the image. So pre-image, change the sign for the image. Okay, so what I'm going to do is just go through one of these with you and then have you do the other 2. So I'm going to do a mapping. Again, we'll just name it. This is a mapping. Okay, so if U, the original U is at negative 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6. So negative 4, 6. That would map to U prime. And then using this rule, negative X, negative Y, all you do is you change the signs. So change negative 4 to positive 4, I change positive 6 to negative 6. So here, I'm going to go 1, 2, 3, 4, and then down 1, 2, 3, 4, 5, 6. Okay, and that would be U prime. So I would like you to pause and figure out V prime and T prime. Okay, so these other 2, V is at 3, 6. So V prime would be at negative 3, negative 6. And then T is at negative 1, 2, 3, 4. Positive 3. So then T prime is going to be at positive 4, negative 3. Okay, so T prime, we're at positive 4, 1, 2, 3, 4, negative 3, 1, 2, 3. Which would be right there. And then I never did do U prime. So U prime is at 4, negative 6. No, I did that one. I didn't do the V. So 1, 2, 3, and then 1, 2, 3, 4, 5, 6 is V. Okay, so my resulting figure would look like that. Okay, a couple of cool things about this shape here. You can notice if you put your finger on the origin here and you rotated the paper 180 degrees, it would be the exact same shape in the same position. So this is actually a 180 degree rotation. So when you have this rule, that is 180 degree rotation. This pen's going to drive me crazy. I'm going to have to figure out how to fix it. Okay, so negative X, negative Y turns into a 180 degree rotation. But also, what it actually is doing is you're changing all of your x values negative. So I'm taking this shape, changing those to be negative. That reflects over the y-axis. And then when I do the negative y, I take that resulting shape and I reflect it over the y or the x-axis. So it's really also considered a double reflection. So 180-degree rotation is also a double reflection. Okay, so last thing. So a couple other good rules that actually just talked about most of these. So as I just talked about, when you have x, y, and you only change the x sign, so you have to think about that logically. You're taking basically, if you have a shape here, you are taking all of the x values that are negative and making them positive. So that is a reflection across the y-axis. Okay, if you think about changing the y values, so if I take this shape and I change all the y values from positive to negative, I'm reflecting over the x-axis. And then as I just talked about, if you do both of those things, a double reflection is actually equivalent to a rotation. Okay, last one. We're not going to do this one very often in this class, but next year you'll do this a ton. This is how you do inverse functions. But if you interchange the x and the y for every coordinate, it reflects across the line y equals x. So the line y equals x, so you should have a little bit of room down here. But y equals x is like y equals 1x plus 0. Right? So you have y-intercept of 0, and then a slope of 1. Dash is not going to work so well. But that is the line y equals x. So when you interchange the x and the y, it actually turns into a reflection over this diagonal line. Okay, you'll do that a lot next year. We are not going to do much with that this year. Great, so this is your introduction into transformation rules. See you next time.